Today, we explore operations with scientific notation. You will learn to add, subtract, multiply, and divide numbers in standard form, and how to apply powers to them. Numbers are expressed in the form a times 10 to the k, where a is between 1 and 10, inclusive of 1, and k is an element of the integers. This is a vital skill for IB mathematics, physics, and chemistry. In the Analysis and Approaches syllabus, scientific notation frequently appears in Paper 1 non-calculator sections to test your manipulation of indices, and in Paper 2, where you must interpret large or small results from your calculator. Today, we are focusing on operations with scientific notation, starting with addition and subtraction. To add or subtract numbers in scientific notation, we must ensure the powers of 10 are identical. This allows us to use the distributive property to combine the coefficients. If the exponents differ, we follow a systematic process. First, identify the number with the smaller exponent. Next, rewrite it by shifting the decimal point so its exponent matches the larger one. Then, simply add or subtract the coefficients. Finally, always check that your result is in correct scientific notation with the coefficient between 1 and 10. Let us calculate 3.2 times 10 to the power of 4, plus 5.5 times 10 to the power of 3. First, identify the smaller exponent. Here, 10 to the power of 3 is smaller than 10 to the power of 4. We shift the decimal point for 5.5 one place to the left to increase its exponent. Now that the powers of 10 match, we combine the coefficients. This gives 3.75 times 10 to the power of 4. Since 3.75 is between 1 and 10, the answer is in its final form. Multiplication is often more straightforward because we utilize the product rule for exponents. 10 to the m times 10 to the n equals 10 to the power of m plus n. To multiply, we first multiply the coefficients together. Then we add the exponents of the base 10 components. The most important step follows. Check the resulting coefficient. If it is greater than or equal to 10, we must adjust the decimal point and increment the exponent to maintain proper scientific notation. Let us calculate 6.0 times 10 to the power of 5 multiplied by 3.0 times 10 to the power of negative 2. We begin by multiplying the coefficients and adding the exponents. This gives us 18.0 times 10 to the power of 3. Notice that 18.0 is not between 1 and 10. We must adjust this. By moving the decimal point one place to the left, we divide the coefficient by 10. To keep the value the same, we must multiply the power of 10 by 10, increasing the exponent by 1. The final result is 1.8 times 10 to the power of 4. Division follows a similar logic to multiplication, but we utilize the quotient rule for exponents. 10 to the m divided by 10 to the n equals 10 to the power of m minus n. First, divide the first coefficient by the second. Second, subtract the exponent of the divisor from the exponent of the dividend. Be careful with negative exponents during subtraction, as subtracting a negative is the same as adding. If the resulting coefficient is less than 1, adjust the decimal point and decrement the exponent to return to standard form. Let us calculate 1.2 times 10 to the power of 3 divided by 4.0 times 10 to the power of 7. We start by dividing the coefficients and subtracting the exponents. 1.2 divided by 4 is 0.3. 3 minus 7 gives us negative 4. Because 0.3 is less than 1, we must shift the decimal point one place to the right to get 3.0. Since we multiplied the coefficient by 10, we must divide the power of 10 by 10, which means subtracting 1 from the exponent. Our final answer is 3.0 times 10 to the power of negative 5. When raising a number in scientific notation to a power, we apply the power to both the coefficient and the base 10 using the power of a power rule. The general formula is, open bracket, a times 10 to the k, close bracket to the n, equals a to the n times 10 to the power of k times n. Intuitively, this is because everything inside the bracket is being multiplied by itself n times. You must remember to raise the coefficient to the power, not just multiply it. If the result leads to a coefficient outside the 1 to 10 range, adjust it as we have done previously. Let us calculate the cube of 2.0 times 10 to the power of 4. We apply the cube to both parts of the product. 2 cubed is 8, and for the power of 10, we multiply the indices 4 and 3. This results in 8.0 times 10 to the power of 12. The coefficient is already in the correct range, so no further adjustment is needed. Let's look at an IB-style question that combines these skills. A rectangular field has a length of 4.5 times 10 to the power of 2 meters and a width of 3.0 times 10 to the power of 1 meters. Part A, calculate the area of the field. Part B, calculate the perimeter of the field. Give your answers in standard form. Part A, area. Area is length times width. Multiply the coefficients. 4.5 times 3 is 13.5. Add the exponents. 2 plus 1 is 3. Adjusting to standard form, we move the decimal left and increase the exponent. Part B, perimeter. Perimeter is 2 times the sum of length and width. To add, we match the exponents. We'll change the smaller one. 3.0 times 10 to the power of 1 equals 0.3 times 10 to the power of 2. Now add them. 4.5 plus 0.3 is 4.8. The final answer is 9.6 times 10 to the power of 2 meters. Let's discuss 3 common mistakes to avoid in your exams. First, students often add coefficients without matching the powers of 10. You cannot add 4 times 10 to the 5 and 2 times 10 to the 3 to get 6 times 10 to the 5. You must match the exponents first. Second, in power questions, students frequently multiply the coefficient by the power instead of raising it to that power. For example, 2 times 10 to the 4 squared becomes 4 times 10 to the 8, not 4 times 10 to the 16, or 4 times 10 to the 8. Finally, many students lose marks by leaving their final answer as, for example, 12 times 10 to the 5. IB examiners require the coefficient to be between 1 and 10. Always do a final check. When using your graphic display calculator, or GDC, use the EE or EXP key to enter numbers in scientific notation quickly. For instance, 4.5 times 10 to the 6 is entered as 4.5 capital E, 6. Unless the question specifies otherwise, the IB requires your final answer to be rounded to 3 significant figures. This applies to the coefficient A in your scientific notation. To maximize method marks, always write down your intermediate steps, especially the addition of exponents, or the matching of powers. Even if you make a calculation error, showing that you knew to add exponents during multiplication can secure you partial credit. Be prepared to interpret your calculator's output. If you see a small capital E on the screen, followed by a number, recognize it immediately as an exponent for base 10. Don't simply copy the E, write it in proper standard form on your paper. Please pause the video now and attempt these 3 practice questions. Question 1. Multiply 2.1 times 10 to the 5 by 3.0 times 10 to the 2. Question 2. Divide 8.4 times 10 to the 6 by 2.0 times 10 to the negative 3. Question 3. Square 4.0 times 10 to the 3 and add the result to 5.0 times 10 to the 6. Pause the video now. Let's go through the solutions. For the first question, we multiply the coefficients. 2.1 times 3 is 6.3. Then we add the exponents. 5 plus 2 is 7. The answer is 6.3 times 10 to the power of 7. For the medium question, divide the coefficients. 8.4 divided by 2 is 4.2. Subtract the exponents. 6 minus negative 3 is 9. The result is 4.2 times 10 to the power of 9. Remember, subtracting a negative increases the value. For the hard question, we first square the term in brackets. Square the coefficient. 4 squared is 16. Multiply the exponent by 2. 3 times 2 is 6. Now we add them. Since the powers of 10 are both 6, we simply add 16 and 5. Finally, adjust to standard form. The final answer is 2.1 times 10 to the power of 7. To succeed with scientific notation in your IB exams, remember these essential points. First, when adding or subtracting, you must rewrite the numbers so they share the same power of 10. Always adjust the smaller exponent to match the larger one to avoid extra steps later. Second, apply the laws of indices correctly. Add exponents when multiplying and subtract them when dividing. Pay close attention to negative signs during subtraction. Third, when raising to a power, remember that the power applies to both the coefficient and the base 10. This is a common place where marks are lost. Fourth, always check your final answer. The coefficient must be at least 1 but less than 10. If it is not, adjust the decimal point and the exponent accordingly. Finally, always round your final coefficient to 3 significant figures as per standard IB guidelines, unless told otherwise.